Hi everyone, my name is Kiara. I am a senior software engineer. I've worked at Microsoft and at Meta, and this is the very first premiere episode of Code Challenge Central, where I'm going to help you to solve coding problems, typically the kind you see on coding interviews. I'm going to solve them in 5 major languages: JavaScript, Python, Java, C++, and C Sharp. And make sure you check the video description. I'm going to note any errors there that I make in the video, as well as any supplemental materials and a link to our Discord so you can join in the fun. Today, we're going to start out with the classic problem of reversing a singly linked list. A singly linked list, just as a reminder, it's a data structure where each node contains some data and a pointer or reference to the next node in the list. The last node just points to null. In this diagram, the list goes from left to right, and to reverse it, we just need to take all the next pointers and point them in the other direction, like this. Then we take the head pointer of the list and point it at the last node, and we're done. But how do we implement this? Let's start by looking at a doubly linked list. So a doubly linked list is where each node contains a reference to both the next node in the list and the previous node in the list. And surprisingly, this is actually easier to reverse. You can just step through the list one node at a time and switch the previous and the next links of each node. The only tricky bit is that you actually have to follow the previous link to get to the next node in the list because you already swapped them. With a singly linked list, though, that approach just doesn't work because you can't point the next pointer back at the previous node if you don't remember what the previous node was anymore. You've already iterated past it. You can search for it again from the beginning of the list if you wanted, but that would take way too long. So to get around this, you need to keep references to at least 2 nodes at all times. Personally, I find it a bit easier to think about this if we keep 3 references: the current node that we're looking at, the previous node, and the next node. We step those 3 references through the list together, like a little train, choo-choo, and just reverse the current node's next pointer as you go. We stop when the next node variable goes off the end and becomes null. Note that here on the final step, we still need to update the current node's next pointer before we stop. To accomplish this in code, we can use a while true loop and break out in the middle. Don't forget, when you're done, we have to update the head pointer to point to the last node of the list, which is now the first node of the list. Sometimes you do this by updating a field on a list class, and sometimes you just return the head of the new list from the function. Another pretty common algorithm you'll see for reversing a singly linked list keeps only 2 pointers instead of 3, the current node and the previous node. Then it creates a temporary variable to hold the next node while it's updating the current node's next pointer. Then it uses that to shift the previous and current node 1 node to the right. Because next is gone now, we have to use current to figure out when to exit the loop. And because current is null when we exit the loop, we have to use prev to update list.head. This is just a little bit more complex, and so I'm going to be doing the 3 variable version in this video. Okay, time for the complexity analysis. Each assignment is a constant time operation, and we do a constant number of them for each node of the list. Assuming there are n nodes, that's O(n) time in all, which is optimal since, of course, you have to modify every node to solve the problem. It requires a constant amount of space, that's O(1) space, just enough for the local variables, since all the changes are actually being made directly to the original list data structure. Note that this is a destructive operation. The original list no longer exists when we're done. We wrecked it. The problem can also be solved non-destructively by building a whole new list. The algorithm is about the same. The main difference is that it requires us to keep track separately of the input nodes and the output nodes, as shown here. This approach requires O(n) space, since of course you're creating a whole new list. For the rest of this video, we're just going to focus on the destructive version. All right, we're going to first solve the problem in JavaScript. So this is actually TypeScript, which is an extension of JavaScript that adds static type annotations. For example, our argument here has type of list of type. This is a type I defined that just has a head field pointing to the beginning of the linked list. And I defined a node type that has a data field for each node, as well as a next field pointing to the next node in the list. If you're using standard JavaScript, you can just ignore all these type annotations. So we're going to go ahead and get started. We need 3 variables to point to our 3 positions in the list: prev, current, and next. Prev is going to start out before the list, which means it's going to be null. Current is going to start out pointing to the head of the list, and next is going to start out pointing to the second node of the list right after that. So you see right away we have an error. It says list.head might be null. And the reason for this is because list could be an empty list. We didn't think about that. It's easiest to deal with that as a special case. If you're trying to reverse an empty list, well, in that case, it's just the same exact list. You don't have to do anything. You're done. All right, that error went away. Now we can write our loop. So this loop needs to do 3 things. First, we need to update current's next pointer to point to the prev node instead of the next node, so that we're reversing it. Next, we have to make sure that we are breaking out of the loop when next becomes null. And like I said earlier, we have to do this after we update this next pointer on current, so that we can make sure that we update the next pointer on the very last node in the list. And finally, we need to update our 3 pointers by shifting them all 1 place to the right. So I'm going to use parallel assignment or tuple assignment to do this all in 1 line. Prev, current, next is going to become current, next, and next.next, just like that. Finally, when we get to the very end, we haven't updated list.head yet, and we can do that by just assigning current. So we're going to give this a run, see what happens. So our input list is 1, 2, 3, 4, 5. You see it got reversed, 5, 4, 3, 2, 1. This is working great. Now we can go down here to where our test code is, and we can change this list if we want to try some edge cases. For example, will this work when the list has length 1? This is an important edge case because we have 3 pointers, and we now have 2 of them pointing off the end of the list. And it worked fine. 1, 1. We can try the empty list, make sure that works. Of course, we have a special case for that, so it should. There we go. That worked fine. So I have pretty good confidence in this now. This is a good habit to get into in any kind of coding interview, just to try a bunch of interesting test cases to make sure your code is working, whether you're trying it by actually executing it or just by walking through it by hand. All right, so now this code is all correct, but I'm going to note one thing here, which is that if we look at prev, it says prev has type any. And that's not great because that means that we could jump in here and write something like this: prev equals ABC. And you know, that'll generate an error later on, but it shouldn't let us do this at all. That's ridiculous. That's not a node. So to fix this, we're going to give this an explicit type annotation where we're going to say this needs to be either a list node or it needs to be null. We're going to use a union type to do that. So now it will no longer allow us to do this, which is great. All right, that is TypeScript. We're going to move on now to Python. Okay, this is our Python implementation. It's going to be very similar to our JavaScript implementation. Again, we're going to be using static types. These are Python 3 static types. This will just help us catch some errors a little bit sooner. This capital list type is not the same as the lowercase built-in Python list type. This is a type I define that has a head field pointing to the beginning of the list. For the same reason, this is spelled LST, not LIST, because that's the built-in Python list. Okay, we're going to set up our 3 initial pointers. I'm going to use next node instead of next because next is a built-in keyword in Python. And then I'm going to assign them initially with none, with the head of the list, and with the second node in the list, just like that. So right away you'll see an error here where it says next is not a known member of none. So what does that mean? It's a little confusing. What it means is list.head here could be a node, could be none. And that can happen if the list is empty. So we do a special case for that. If the list is empty, we're just going to return. The reverse of an empty list is the same list. All right. So, oh, and these errors are just that these are unused. We're going to use them in a second. We're going to start our loop. And we're going to, let's see, start out by pointing the next pointer of current at the previous node instead of the next node. So we're reversing the link. Next, we're going to check if we've reached the end. If we have, next node is none. Then we're just going to break out of the loop. Otherwise, we're going to go ahead and shift all 3 pointers, one to the right. And we're going to use parallel assignment to do this all in one line. So this is going to get current, next, and, next node, and next node dot next, just like that. All right. Now we're going to finally update head to point at current and give it a run. Now you can see our output says 1, 2, 3, 4, 5 got reversed, 5, 4, 3, 2, 1. Everything worked. And we're going to go ahead and go on to Java. All right, our Java implementation is going to be quite similar to our JavaScript and Python implementations. I'm going to go ahead and create a node for previous, for current, and for next. Previous is going to be null. Current is going to point to the head of the list. Next is going to point to the node after that. We need to remember to check for the case where the list is empty. And in that case, we'll need to return right away. Then we're going to have our loop. We're going to update current.next to point to prev. We're going to check if we're at the end of the list. If so, we go ahead and break. And finally, we're going to update prev, current, and next to point one node to the right. So we don't have multiple assignment or parallel assignment in Java. So we're just going to write 3 statements on one line to kind of simulate that. Prev equals current, current equals next, next equals next.next. So in general, you can't always replace parallel assignment with sequential assignment like this. For example, if I tried to replace st equals ts with s equals t, t equals s, that would just assign the same value to both. So in this case, it works because we don't overwrite current until we've used it. We don't override next until we've used it. But in general, you got to watch out for that. Finally, we assign list.head to just point at current, and that should do it. Let's give it a run. One moment. Run. Debug. And we have our reverse list. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Looks good. Let's go ahead to the C++ edition. All right, this is our C++ implementation. It's going to be very similar to our Java implementation. We're going to have a node prev, a node current, and a node next. Notice that we're using pointers here because these nodes are allocated on the heap. We're going to set the first one the null pointer before the first node of the list. This is going to be the first node of the list. And this is going to be the node after that, the second node of the list. Notice that we use an arrow here because, again, this is a pointer. We do need to check for the case where the list is empty. I like to write equals null pointer. Some people like to write if not list head. You can do it either way, whatever you prefer. We will return in that case because the reverse of an empty list is just an empty list. Now we do our while loop. And I'm going to set current next to prev instead of next. That's switching the pointer around. If we are at the end of the list, next equals null pointer, we're just going to break. And finally, we're going to shift all 3 pointers one to the right. Prev equals current, current equals next, and next equals next, next, like that. Note that this is the next field, this is the next variable. Don't mix those up. Finally, list.head equals current. And we should be done. Let's give it a run. All right. And you can't see it, but I'm going to drag it over here and show you. The list in the console window, 1, 2, 3, 4, 5, it reversed. It's 5, 4, 3, 2, 1 now, just as desired. So now we're going to go ahead and go to the final language, C#. Finally, the C# version. So we're going to use type inference here just to declare all three variables compactly. We're going to have var, and then we're going to have prev, current, next. We're going to declare all of them. We're going to set prev to null, current to list.head, the first node, and next to list.head.next, which is the second node. Now, you're going to see some errors here, and it says cannot infer the type of implicitly typed deconstruction variable. And all that means is that it sees null here, and it can't figure out what type it is, because null could be like any reference type. So what we're going to do is we look at the type of list.head. We see it's node t question mark, and we're going to use the exact same type here for null, node t question mark. And that fixes those errors. To explain what this question mark is, in recent versions of C#, they added strict null checking, which lets it give warnings like this, where it says dereference of a possibly null reference. It knows that list.head is possibly null because it has this type with the question mark. If there is no question mark, then it cannot be null. It's not allowed to be null. If it has the question mark, then it is. All right, so I should actually fix that. We need to check for the empty list case. And just return if that happens, because in the reverse of an empty list is the same list. Now we have our while loop, and we're going to set current.next to prev because we want to point at the previous node. We're flipping it around. And then we're going to check if next is at the end of the list. If it is, we're going to break. And finally, we're going to use multiple tuple assignment again to shift all these guys one node to the right. Prev equals current, current equals next, next equals next.next. And finally, we're going to just update the list head, point it to current, and that should do it. Let's give it a run. And you can see here that we have our 1, 2, 3, 4, 5 has become 5, 4, 3, 2, 1, and it's working. I hope you enjoyed this first video. This is my first time doing something like this. So if you want to see more like this, like, comment, and subscribe. And in particular, if you have any questions or concerns about what I said in the video, drop them in the comments. I'll be sure to read them and answer them. And if you also have some ideas for other problems, that would be great to cover and to solve, let me know. This is Kiara at Code Challenge Central, signing out.